When a supply chain breaks down, it looks like a random stroke of bad luck, a late shipment, stock out, or a sudden spike in transportation costs. But these failures are rarely random anomalies. They are symptoms of hidden systemic flaws buried deep within the operational network. To find and eliminate those flaws, top-tier operational teams rely on structured problem solving. This methodology, rooted in standards set by the Association for Supply Chain Management, or APEX, and elite consulting practices like McKinsey, treats operations as a rigorous science rather than an art. The core rule of this approach is simple: you diagnose before you decide. Professionals operating at this level refuse to treat surface-level symptoms, and they do not commit to a solution until the exact underlying mechanics of the failure are mapped and verified. This stands in direct opposition to unstructured management. In an unstructured environment, problem-solving is entirely ad hoc. Decisions are driven by gut intuition, immediate panic, or whoever holds the highest rank. A structured approach replaces hierarchical guesswork with hard logic. It is fact-based, cross-functional, and driven by testable hypotheses. The entire diagnostic path is transparent, meaning anyone can follow the math from the initial symptom down to the exact point of friction. Without this discipline, organizations are trapped in a cycle of perpetual firefighting. With it, they build a scalable architecture of institutional logic, where every solved problem strengthens the resilience of the entire system. Dissecting an operational crisis requires a strict sequential architecture. There are 6 specific steps to move a network from a state of failure back to stability. Step 1 is problem definition. You must clearly and quantitatively document what is breaking and the exact magnitude of the failure. Most importantly, this definition must never contain a premature guess at the solution. Step 2 breaks the problem apart. We use a principle called MECE, which stands for mutually exclusive, collectively exhaustive. This means dividing the operational problem into distinct categories that cover every possible variable without any overlap between them. Step 3 is identifying the root cause. This involves formulating strict hypotheses based on your MECE categories and testing them against empirical data to isolate the true origin of the failure. Steps 4 and 5 force the team to develop multiple solution options, evaluate the operational trade-offs like cost, service level, and risk, and finally implement the optimal path based entirely on the data. Step 6 is monitoring. You track the data over time to verify that the performance gap is permanently closed and that your fix hasn't created unintended consequences elsewhere in the supply chain. This sequence is rigid by design. Skipping any step in this framework transforms a scientific diagnostic process into a dangerous guessing game. Let's apply this framework to a live environment. Imagine you are the regional supply chain manager for a fast-moving consumer goods distribution network. This chart shows your primary service metric, OTIF, which measures orders delivered on schedule and in the correct quantity. Your target is 95%, but over the last 3 months, performance in Region East dropped sharply to 88%. The standard, unstructured reaction to this drop is immediate panic. Sales escalates the issue, customers complain, and someone in management assumes the solution is simply to increase safety stock to buffer the network. That reaction is exactly what Step 1 is designed to prevent. Before spending a single dollar on inventory, you must establish a sterile, bias-free problem statement. You build this statement by isolating the facts. The what is the OTIF decline. The where is Region East. The when is the last 3 months. And the magnitude is a -8 percentage point gap against the target. This hits the cardinal rule of problem definition. OTF has dropped 8 points in Region East is a valid factual statement. OTF has dropped because we need more safety stock is an assumption disguised as a diagnosis. Establishing a perfectly constrained factual statement aligns your cross-functional teams. It strips the emotion out of the room and neutralizes the operational panic. With the problem defined, you deconstruct the overall OTF metric into its mutually exclusive components, on time and in full delivery. The data shows in full remains stable at 98%. On time is the driver of the decline, having fallen to 89%. This single data point disproves the initial assumption. The network doesn't have an inventory availability issue. The products are sitting in the warehouse. The failure is strictly tied to delivery timing. Now you divide that on-time failure into MECE functional buckets, guaranteeing no overlapping theories. Timing is dictated by 5 areas: planning, plant output, transportation, DC dispatch, and master data. These 5 categories form the strict boundaries for your investigation. Every potential cause must fit neatly into one of these specific functional groups. The MECE framework acts as a mathematical scalpel. It systematically cuts away irrelevant noise and exposes the exact area of friction. Moving to step 3, you formulate and test hypotheses against the hard data. Hypothesis 1. Did an increase in forecast error cause cascading delays in the supply schedule? You look at the MEPE, which measures forecast accuracy. The data shows MEPE has remained stable at 22. The forecast is not the issue. Hypothesis 2 looks at plant delays, but the manufacturing logs show a 97% schedule adherence rate. The plants are producing on time, eliminating supply as the cause. Charting the third hypothesis, transportation delays, reveals an anomaly. Carrier OTIF dropped to 87%. Deploying the 5 whys exposes the root. Carriers shifted capacity to higher margin customers, reducing available trucks. This was missed due to failing to review scorecards in the S&OP process. S&OP stands for Sales and Operations Planning, the process that aligns demand, supply, and financial planning. By failing to include transportation data in these meetings, the team missed the capacity crunch until it hit the customer. If the team had treated the initial symptom by increasing inventory, they would have incurred massive holding costs to store products that still wouldn't reach the customer on time. They would have spent millions without touching the actual constraint. Step 4 evaluates operational trade-offs using a decision matrix. Option A, increasing safety stock, and Option B, premium freight, improve short-term service but fail scalability and ignore the root cause. Option C is chosen, a systemic fix rebidding lanes and updating ERP lead times. ERP, or Enterprise Resource Planning, is the software that manages core business processes. By updating the lead times in the ERP, you ensure the planning software is using real-world data to calculate delivery dates. You move to steps 5 and 6, execution and monitoring. You implement the new carriers and officially integrate a weekly carrier performance review into the S&OP agenda, so this data is never ignored again. 6 weeks later, the results are empirical. OTIF recovers to 95.2%. Expedite costs drop by 18%. The sales escalation is formally closed. Data-backed structural implementation permanently resets the organization's operational baseline. Because the solution addresses the root cause directly, this specific mode of failure is effectively engineered out of the entire system. Despite its effectiveness, veteran managers often object to this framework, claiming that structured problem-solving is simply too slow for a fast-paced environment. This reveals an operational paradox. Structured diagnostics do require more time up front to run the math and map the logic. However, by definitively isolating the root cause and preventing recurrence, this methodology reduces the total time an organization spends resolving the same issues. There is also a dangerous industry myth that experience alone is enough to manage a complex global supply network. Relying solely on tenure creates a culture built on undocumented, unstructured intuition. When a veteran manager leaves, their internal logic leaves with them, creating a massive single point of failure for the company. Experience is valuable, but experience without a formal framework is the practice of repeating the same operational mistakes with increasing confidence. The ultimate value of this framework is the discipline it forces upon leadership. It demands that a team stop treating superficial symptoms and start systematically hunting down systemic root causes. By utilizing the logic championed by organizations like Apex and McKinsey, you guarantee that your teams are solving the right problem with the correct solution, supported by empirical data. True operational excellence is never an accident of experience. It is the deliberate result of relentless, structured logic.